Oil chemistry secrets. That's today's cook. And yes, I'm leaning into a little Breaking Bad vibe to make real chemistry easy. What if Walter White made motor oil? Would he follow the recipe or go rogue? I'm Morgan Lane, and you're watching Recall Roadmap with Morgan. Here's the twist most folks miss. Motor oil isn't just oil. It's a strict lab recipe. Change the mix, lose the badge. Industry journals show the big four additive houses: Lubrizol, Infineum, Chevron Oronite, and Afton supply most of the chemistry that ends up in bottles. Modern oils are roughly 20% additives and about 80% base oil. Inside that additive portion, about 70% is detergent and dispersant to keep engines clean, and roughly 30% is viscosity improver to control thickness as temps swing. We checked this against lab data and real test programs. The additive pack we use later is already proven to meet tough specs. So, what actually goes into the bottle? And what happens if we change it? Here's the plan: additives, base oils, the API tests, then our Outlaw experiment and results. The recipe is tight for a reason. But what if someone decides to switch things up? Drop this in the comments. Pick one: Mobile or Castrol? Which do you trust? And did you know they often rely on the same additive labs? Think you know your oil brand? Here's the reveal. Most bottles on the shelf start from the same handful of chemistry kits. Four giants: Lubrizol, Infineum, Chevron Oronite, and Afton design the additive packages that do the heavy lifting. Oil marketers buy these concentrated cake mixes, then blend them with base oils to hit a specific spec. That's the quiet truth the industry has run on for years. It's not magic, it's engineering and validation. In those additive packages, the bulk of the volume is not wild secret sauce. It's practical chemistry. About 70% is detergent and dispersant, the stuff that keeps varnish, soot, and sludge from baking onto metal. Around 30% is viscosity improver, long-chain polymers that help your oil stay thin in cold and not go watery in heat. Different brands tune feel and marketing, but the backbone comes from these labs and their test programs. That's why datasheets sometimes hint at which package sits inside a blend, or list performance claims that mirror the pack's abilities. Knowing most oils share these kits helps cut through brand noise. If so much starts the same, what happens when a blender alters the mix? Even a little. Let's mess with the recipe next. DIY chemists dream of a custom oil. But here's the suspense. A single tweak can break the license. When a bottle wears the API quality mark, that mark is the marketer's warranty that the oil meets the full set of API 1509 requirements. That means the recipe that passed all those engine tests must be the recipe in the bottle. Swap an additive, change a treat rate, or switch a base oil group without retesting, and the warranty is gone. It's now an unlicensed outlaw oil. Automaker specs can be even stricter. General Motors' Dexos1 Gen 3 demands that each viscosity grade match the tested formula exactly. Any deviation, and it's no longer approved. That precision exists because modern engines run hot, fast, and clean, with tiny clearances and turbo heat. The protection window is narrow. So could a clever homebrew meet spec? Not without the brutal testing that proves it under knock, wear, deposits, and low-speed pre-ignition stress. The rules are tight by design. So we heard the warning, we understood the risks, and we did it anyway. We changed a proven mix on purpose. What happened next when we actually ran it? Before we pour, we need the beaker basics. Not all oils start the same. Most of what's in your bottle is base oil, often 80 to 90% of the total. The American Petroleum Institute groups base oils into 5 categories. Groups 1 through 3 come from crude oil refining. Group 4 is synthetic PAO. Group 5 is the catch-all for other synthetics like esters and silicones. As you climb the groups, the oil gets cleaner, more stable, and better at handling heat and oxidation. That's why most modern engine oils lean on Group 2 or Group 3 bases. They have very high saturates and low sulfur, so they stay stable when the engine bakes them. Full synthetics often use Group 3 or Group 4 to hold viscosity across seasons and resist deposit formation. The base sets the stage. Additives do the acting. Together, they make an oil that can pump fast when cold, cushion parts when hot, and keep metal spotless. Now that we've got the ingredients on the table, the next piece is the rulebook. What locks that recipe in place? And what does it take to wear the official marks on the label? Let's open the API playbook. Here's the gate you must pass. The API license is not just a sticker. It's a process and a promise. Oil makers submit the exact formula and pay a license fee of $6,000. Then come the hard parts. The engine tests and lab protocols defined in API 1509 for categories like API SP and ILSAC GF 6. You can't display the API quality marks, the donut, the starburst, the shield, until you clear that process and get approval. In practice, that means months of controlled runs on specific engines to prove wear control, deposit control, oxidation resistance, and more. That's why the recipe is locked. If you change it, you owe the test program again. It's fair, and it protects drivers. Always check your bottle for the API marks or the automaker's spec callouts if your car requires them. If the label is vague, I get cautious. Quick break for you and me. If you're into clear, safety-first car science, hit subscribe. It keeps these deep dives going and helps me fund more test time. Rules are clear, so we went rogue anyway. Time to see what happened in our lab when we stepped outside the lines. Time for the verdict you came for. We built an Outlaw Oil and ran it. Our baseline was Afton's high-tech 11183 additive package. It's fully qualified to meet ILSAC GF 6 and API SP when used as directed, so it's a solid, proven starting point. Then we altered the treat rates. We nudged one component up and pulled another down. Small change on paper, big change in reality. That single move meant our blend no longer matched any approved formula. By rule, it could not be licensed unless we went through a full retest program. We set up a controlled engine run with matched conditions, same fuel, same filter, same duty cycle. First the certified mix, then our modified blend. I watched torque readings, oil temps, and pressure. After each run, we pulled samples for used oil analysis to look at wear metals, like iron and copper. The Outlaw blend showed higher internal drag and rising wear markers compared to the baseline. Not a blow-up, but enough to say the chemistry balance mattered. We did it to prove a point, and it did. We broke the recipe. The engine told us. Now, what did those results look like in detail? Here's what the data said, clean and simple. With the certified mix, the engine settled in smooth, stable torque for the same duty cycle, and oil analysis came back with wear metals well within expected range. With the Outlaw blend, average torque to hold the same speed crept up, a clear sign of extra friction inside the rotating assembly. After the run, the oil sample showed elevated iron and copper versus baseline, classic flags for higher wear on cylinder liners and bearings. We didn't change fuel, load, or hardware. Only the oil. That's why I trust the signal. A small formulation swing changed friction behavior and protective film strength. You could feel it in how the engine pulled and see it in the jar. No panic, no engine death, but enough drift to say, don't guess with chemistry. That's the trap of homebrews and off-recipe blends. The lab tells the truth every time. We saw the engine respond to our choice. So if getting it right matters this much, what does it actually cost to prove a fresh formula the official way, from start to finish? Testing costs rocket fast. The license application itself is $6,000, and renewal is $6,000 again, with a $1,000 late penalty if you miss the date. There's also a small volume fee, about $0.008 per gallon, beyond 750,000 gallons, that helps fund the program. But here's the real bill, the engine and lab tests. Each official test stand rental can run into the tens of thousands, and you need multiple runs across wear, deposits, volatility, oxidation, and low-speed pre-ignition. Add development time, base oil studies, and verification, and total spend climbs into the hundreds of thousands of dollars for a new formulation. Sometimes more. That's why marketers lean on proven additive packages. The pack supplier has already done a huge chunk of that heavy lift. The $6,000 fee is just the key to the door. The house behind it is expensive to build. Given that price tag, rolling your own blend without validation is a gamble. So, is going rogue worth it? For me, not when real engines and real warranties are on the line. Which brings us to the last most important piece, your car's protection. Engines don't forgive guesses. Automaker specs exist to keep your parts safe and your warranty intact. The additive package we based our test on is designed to meet industry license requirements for engine warranty protection under ILSAC GF 6. On top of that, GM's Dexos1 Gen 3 adds extra demands for cleanliness and wear. Meeting those higher bars takes careful chemistry and proof. When you drift off recipe, you lose those guarantees. If a failure happens and the oil doesn't meet the required spec, a manufacturer can point to that and deny coverage. Beyond paperwork, the risk is mechanical. Modern engines run tight, hot, and often boosted. They need clean detergency, stable viscosity, and strong anti-wear to prevent LSPI deposits and scuffing. That's what licensed oils are tuned and tested to deliver. An unlicensed Outlaw blend might feel fine for a while, but every mile is a bet you don't need to make. Use the spec your owner's manual calls for, API, ILSAC, or OEM labels like Dexos, and you protect both engine and wallet. We've seen how reality beats shortcuts. Now let's land this plane with a clear takeaway. So, what if Walter White made motor oil? He'd learn fast that the cook is a recipe, not a vibe. Most brands start with the same big league additive kits. Base oils set the canvas, additives paint the picture, and the API rulebook decides if it goes on a wall. We went rogue in a controlled test, and the engine told the truth. Small changes shift friction and wear. The costly certification process exists to protect your car. Follow the recipe and you keep both performance and warranty on your side. This is Recall Roadmap with Morgan, and my bottom line is simple. Licensed oil isn't hype, it's insurance. I'd love your vote for what we test next. Pick one in the comments. Should we put AmSoil through this same rig, or run a filter-only wear test to isolate capture efficiency? Thanks for watching, and if you want straight, safety-first car science each week, hit subscribe and share this with a friend who loves a good lab story. Take care out there and keep your engines safe.